What up, guys? How's it going? Help you with learning standard deviation as well as ACT, SAT, Z-scores. So thanks for being here. Thanks for watching at home and learning. Be some new stuff today, so definitely glad you're watching this video. To start off, I'd like you to meet my friend Godzilla. He wanted to make an appearance today, and here he is. Whoa, is that pretty cool? Got that for my grandkids. Look what he does. Yeah, so cool. So let's see here. So starting off, we learned last week about doing 5-number summary, minimum, maximum, Q1, Q3, median, and then 5-number summary, and then making a box and whisker plot, right? Just like this, where your minimum, Q1, median, Q3, maximum, make your box and whisker plot up. Let's learn the IQR is 50% of your data. Awesome. So something new that we're going to be learning today is the standard deviation, as well as doing Z-score. And so Z-score is super easy. And it's got the standard deviation in it. Usually standard deviation is given to you. Let's see here. But also, so we did 5-1, we did outlier rule, we did 5-2. Awesome. We did modified box plots. And so modified box plots are box plots with stars in them, as you can see here, with stars to represent the outliers. And you get a new minimum and a new maximum. So we'll be doing a little quiz, testy test on this. So it's good to review, watch my videos again, watch my videos again. And to make sure you know how to do this so you ace the test. Okay, so then we did 5-2. And here it is. So the median, this is how it works, okay, to try to connect your knowledge. So the median is the center with the 5-number summary. Median's the center, and it spreads outward of Q1 and Q3, minimum, maximum, okay? So the 5-number summary is a good way to describe the center, or median, and the spread, how far apart our data is, the variation, the variability. So however, when predicting with data, there's another more accurate way to predict using a different center and spread. We use the average. That's right, we use the average. And so what's the spread? Well, the average is the center, just like the median. But what's the spread when you're dealing with the average? So the spread is the standard deviation. Okay? So we're going to learn what that is right now, and then Z-score and empirical rule after that. So if you have outliers, you definitely want to use the battle axe. Swing that battle axe, it hits everything in its way. So if you have outliers, median doesn't get affected by outliers, so use the median as well as the min, max, Q1, Q3. Now, if you're going for a nice, sharper prediction, boom, with the sword, stab. So a standard deviation. So you definitely want to use the average and standard deviation. Cool. And so that's if the data is symmetric and there's no outliers, is when you want to use the average, X bar, and the standard deviation, also known as capital S, lowercase x. Cool. Okay, well, how do you calculate the standard deviation? Let's see. Well, we figured out how to find the median, working in the middle, Q1, Q3. But now, how do we calculate the standard deviation? Oh, wow, look at this keyboard and all these buttons. Isn't that fun? Yeah, what a great keyboard. And so let's see, it's the new keyboard for the statistics lab. Once you learn how to use it, it'll make computation of the standard deviation even easier. No, it's not that bad, I promise. It's not that bad. Okay, so here's the definition. Why they use measure variability. Found by calculating the difference between the mean and each observation, squaring the value for each observation, adding the squares, dividing the sum by one less than the sample size, and taking the square root of the whole thing. So here's the formula that we did for the vocabulary test. And so it has a big old square root symbol. This symbol right here is called, do you know what it is? Do you know what it's called? So it's the summation symbol, add them all up. So it's a capital sigma is what that is. So capital Greek letters, sigma. Awesome. So just a fun fact there. Just wanted to share that with you. Ooh, capital sigma. Awesome. Okay, then over here again is x bar, which is the average. This means to square them all. Good. And then this xi represents each of your data, each of your numbers in your data set. Okay, and then instead of adding them all up, dividing by n, because that's what this means, to add them all up, divide by n minus 1. So n minus 1, n is your sample size again. That's your number of numbers, and then minus 1. So we identified the parts of the standard deviation. Now let's give it a try. Okay, let's first try with the following 3 numbers. 1, 3, 5. What do you guess the standard deviation is? What do you guess? Make a guess. Just guess. Let's see if you're right. Okay, so the first thing we need is that average, right? We have each data set, but we need the average. So do you remember how to find the average? So you add them all up. So 1 plus 3 plus 5. This is called the x bar, or the average. So 1 plus 3 is 4. 4 plus 5 is 9. And then, so oops, here's the 9, sorry. So we have 1 plus 3 plus 5 equals 9. You add them all up and divide by how many numbers you added, which was 3. So that's going to give us the average, which is just 3. Interesting. So we'll go ahead and give that a different color, 3, just because when we do our formula, so you can see the difference. Okay, so now we're going to do capital S, lowercase x. This is finding the standard deviation by hand. There's also, it's on your calculator, which I'll show you how to do next. As well as, you can probably even just Google standard deviation calculator in Google, and it'll say to enter your data set, and then it'll do it for you. We'll show that next too. Okay, so you do a big ol' square root symbol, right? Big ol' square root symbol. So we're going to do the standard deviation of. Okay, really big there. Okay, so now we're going to do the summation of. We're going to do each data set minus its average and then square it. So let's give that a try. Okay, so first of all, we've got the number 1. So we're going to go ahead and bring that down. So the first number in our data set is 1. Nice. And then we're going to minus, and then we're going to minus the average. Well, the average is 3. So 1 minus 3. Again, that's the average right there. So 1 minus 3, so it's the person's score, or the individual data number, minus the average, all squared. And then remember, this summation symbol here means to add them all up. So next, we're going to go ahead and do a plus. And then we're going to do the next data. So where did we get this 1 from? Sorry? We got this 1 from right here. So 1 right there. And then the average, which is 3, went right there. Cool. Okay, so then the next number is 3. And so 3 is now going to go here. So 3 minus a different number 3. Remember, our different number 3 is the average. Cool. Then all squared plus our last number. And so our last number is 5. And so we're going to go ahead and bring 5 there next. Again, following the formula, minus the average. Sorry about that. So the average is 3. There we go, all squared. Okay, last but not least, we're going to add them all up and then divide by how many are there. And so we're going to actually do not just divide by 3, because 3 different things we've added, but we're going to do 3 minus 1, right? The sample size 3, but minus 1. And so this is n minus 1. Let's put this over here. So this is to account for any error in our data collecting, okay? So always divide by n minus 1, okay? It's called degrees of freedom is what that's called, n minus 1 degrees of freedom. And so our n is our total number of numbers there, so in this case, our n equals 3. And so we're going to do 3 minus 1. So I'll put that in green just because that's part of the formula. Minus 1. Cool. So this will be a homework problem that you'll just get the answer right now and multiple choice matching to say thanks for watching the videos. Nice. Sorry, dry throat. Need a drink? Remember in class when I always needed a drink. Okay, so now we're going to finish this. Awesome. Okay, so now we're going to do the standard deviation of, ready? So 1 minus 3 is negative 2, right? 1 minus 3 is negative 2 all squared. Plus 3 minus 3 is 0 all squared. Plus, that's supposed to be all squared. Sorry. Don't be so sloppy, Mr. Newbold. Okay, so that's 0 squared. It's hard with the mouse, okay, guys? Plus 5 minus 3 is 2, all squared. Okay, and then all of that is divided by 3 minus 1 is 2. And all of this is under the square root symbol, okay? Equals, here we go. So negative 2 times negative 2 is a positive 4, right? Positive 4. Plus 0 squared is just 0, so that goes away. And then 2 squared is 4. Cool. All divided by 2. This is really looking good. So then we get the square root of 4 plus 4 is 8. And 8 divided by 2 is 4. And the square root of 4 is 2. The standard deviation is just 2. Isn't that fun? Nice. So that was a cool way to find the standard deviation. So the standard deviation equals 2. Homework answer on our canvas. Okay, so it's 2. So then let's kind of talk about this. Now this isn't exactly true, but it's to give you an idea of what the standard deviation is, okay? So this is 135. Hey, you're not paying attention. Look, I'm pointing to you. Yeah, listening, Mama. Come on. That's it. Mouse close. Oh, good. You're paying attention. Okay, so 135 is our numbers, and the SD, the standard deviation, equals 2. So that's basically the how do we say this? This is to help you understand what we're doing here. So it's the average distance from the center of our data to the other numbers in our data set. Okay, the average distance from the center of our data to the other numbers in our data set. Now this one's really easy because it's just basic numbers 1 through 5, and then we'll do a more complex, or not, just slightly more difficult, not really. Okay, there we go. So now we're going from, remember, so our standard deviation is 2. Well, guess what? What's the distance from 1 to 3? 1, 2, 3. That's a distance of 2. What's the distance from 3 to 5? Right? What's the distance from 3 to 5? 2. And so we average those together and we get 2. Woo! Does that make sense? So our standard deviation average distance is 2, which is our standard deviation after all that beautiful work. Okay, so now you try. Here's our numbers. I'm going to go in and pause me. Pause me. I want you to try now. And if you're feeling lazy and you don't want to try, still pause me. Try it. I'm waiting. Okay. I want you to make a guess at least. If you're not going to try, no, you should try. Just pause it. You'll get it right. Just try. Okay, so just go and make a guess. What do you think? What are some guesses? Shout it out so I can hear you. Oh, you said 3? Cool. That's a good guess. What else is there? Take another guess. 4, good guess. We already did 2, so probably not 2. Maybe 2.5. Okay, so these are all good guesses. Nice. Okay, so then if you remember how we set it up with our standard deviation, we go capital S, lowercase x. Awesome. Then you remember we do a huge square root symbol. And then we take each of our numbers. How many numbers do we have? Yeah, we got a ton of them, don't we? How many do we have? We have 5 of them. So that's why I have 5 parentheses, okay? Barney Notch, Wendy Barney Notch. Name drop, Mrs. Barney. Okay, so we're going to take each of those 5 numbers and we're going to minus them against the average, right? Okay, so in this case, our average is going to be 5 because it just happens to be symmetric. It's not always, but this is kind of symmetric. So 1 plus 3 is 4. And then 4 plus 5 is 9. Plus 7 is 16. Plus 9 is 25. So we have 5 numbers that add up to 25 divided by 5. And that 25 divided by 5 is just 5. Okay, so our average in red is 5. So let's go ahead and do that to make it red. Okay, so our average is, our x bar is 5. So that 5 is going to go here, 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 and here. Awesome. Nice. Okay, so then we go through and we do each of our numbers in our data set, right? So that means it's going to be a 1, a 3, a 5, a 7, and a 9. Okay? And then do you remember what we do in between each one of those? We add them all up. That's right, summation, add them all up. And what else do we do? We square them all. That's right, square them all. Now I'm going to try to do some of this in my head. You can look back to the previous problem for all the little basic steps here, but we're going to try to do some overhead. Now we have 1, 2, 3, 4, 5 numbers, so n minus 1 or 5 minus 1. Awesome, here we go, let's square them all. Okay, so then we get the square root of 1 minus 5 is negative 4. Negative 4 squared is negative 4 times negative 4 is 16. 3 minus 5 is negative 2. And then negative 2 squared is a positive 4. So if I'm not completely showing my work there, okay, that's just going to be 0 squared because it's the center. Cool. Not always, but yeah, for the most part. Well, not always. Okay, 7 minus 5 is symmetric data. 7 minus 5 is 2, so 2 squared is 4. And then 9 minus 5 is 4, and again 4 squared is 16. Awesome, I made a mistake. Did you find my mistake? Where's my mistake? Can you see it? What's the formula? N minus 1 Newbold. Oh, I don't know why I took away 1 off 5. Sorry. Okay, so it's 5 minus 1. Cool. Okay, so that's all divided by 5 minus 1, and that's where I get the 4 from. Cool. 16 plus 4 is 20. 16 plus 4 is 20. 20 plus 20 is 40. Nice. So 40 divided by 4 is 10. And so the square root of 10 is our standard deviation. Now if we want to go ahead and turn that equivalent into our decimal, which will probably be on the homework for Canvas, and let's also verify real quick. So if you want to just go to Google and type in standard deviation calculator, I'm sure there's plenty out there to help you, or if you want to use your graphing calculator, that'd be awesome too. Okay, let's see here. Maybe just use this calculator.net. It's pretty cool. So it says to type in your data set with commas. So 1, comma, space 3, comma, space 5, comma, space 7, comma, space 9. And then we, it's just a sample. Then we go ahead and do calculate, and it tells us 3.16227, blah, blah, blah. And it shows you all the steps, how to do it, like I just showed you. And then we get the square root of 10 is 3.1622. Awesome. So you can just use this for the homework or the test or the practice test, whatever. So just use standard deviation calculator, calculator.net. Might even throw it in the Canvas website just to help you there. Okay, awesome. Okay, so that's 3.1622. So 3.1622. Awesome. There we go. Okay, so now you try. So here's another homework problem. We're going to have you practice just once here because I think you'll get the hang of it. You can use your calculator. In fact, some of you just have your graphing calculator. You don't want to use the website maybe. And so let's just see. Let's just show you how to do it on the graphing calculator. Again, it's just one of our stats. So really, if you have your graphing calculator, you pretty much kind of already know how to do it, right? Awesome. And then we'll do another video next on how to do z-score, because that's pretty easy. And that'll also be on the Canvas homework, which is awesome too. It's being so slow. Open. Oh well. Okay, so then while that's loading, so empirical rule. We'll talk about the empirical rule while that's loading. This rule, which applies to only mountain-shaped distributions, tells this rule or law, hint, hint, wink, 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 vocabulary test. So this rule or law only applies to mountain-shaped distributions. Tells a person the data is found within 1, 2, and 3 standard deviations of the mean. Okay, so it's basically a rule, a law to memorize that talks about the standard deviations. Finally, how long did that take to load, right? Okay, so thanks for your patience here. So we're going to go to stats, we're going to go to edit our data, we're going to go and erase this data and type it in. Do you remember how to type it in? So first let's clear it, there we go. Again, I went to L1, I push clear, I push enter, and then we type in 1, enter 3, enter 5, enter 7, enter 9, enter. Then we go to stat buttons, we go over to one var stats, we do list 1, and there it is. Our standard deviation was there the whole time in one var stats. So it's 3.16227766. So that's our standard deviation. So use the capital S, lowercase x. That's for sample standard deviation. And this is sigma standard. Don't worry about this. It's just for population. No, no, no. So just use that one. Give me 1 second. There we go. Show you with our graphing calculator. Bam. So again, it's 3.16227. So use your graphing calculator to help you on the homework. We'll have you do a couple standard deviation problems, just 2 from the video and probably 2 for homework. Now you try. So give it a try. Do 1, 5, 5, 6, 6, 9. See if you can find the standard deviation of that for your homework. And that'll be on Canvas, which is awesome. Cool. Okay, so then next we'll talk about the empirical rule and standard deviation. So thank you. Thanks for watching. Like my hat? St. Patrick's Day, only $1.50, 75% off Walmart. I'm also wearing this shirt that says, let the shenanigans begin. I don't know, I don't want to think about past. We missed St. Patrick's Day. I saw you for a second, and then we came home. So thanks for watching, and peace out, and watch the next video. Thanks for learning standard deviation with me. Sorry this video is long, but standard deviation is more complicated. Z-scope easy, empirical rule, really fast, maybe 6-7 minute video, pretty fast. Thanks for watching. Peace out. Woo! Peace out, brother.